Here we are looking at two inequalities that involve absolute value expressions as well as greater thans in the direction of the inequality. The thought process here is very similar to the ones we saw before with the less thans, but instead of looking for one stretch on the number line to find our solution values, we're going to end up looking for two different stretches of the number line. And here's why. Number line. And our target point on the number line is going to be 11 in this case. And so I'll put negative 11 and 11. And think about this expression, which tells us that we've got this 3x minus 1 thing. The absolute value of this 3x minus 1 thing needs to be bigger than 11. So where can 3x minus 1 itself come from? Well, it can't come from here because there the absolute value is less than 11. Similarly, it can't come from in here because there the absolute value of 3x minus 1 would be less than 11. 3x minus 1 could live out here, and if it lives out there, then its absolute value is certainly bigger than 11. And it could have lived over here, or I should say, it could have lived over there, in which case the absolute value of 3x minus 1 is greater than 11. If 3x minus 1 happens to be negative 15, its absolute value would be 15, which is bigger than 11. And so we can write down this scenario algebraically. It won't be a compound inequality in one expression like in the last examples. What we're going to have to do here is just write down the two possibilities separately by saying that, look, either 3x minus 1 was bigger than 11 to begin with, so its absolute value is greater than 11, or 3x minus 1 was less than negative 11, in which case its absolute value would have been bigger than positive 11. So these are the two cases to track down. In this case, we add 1 to both sides to give 3x is greater than 12, which means x is greater than 4. And then over here, let's add 1 across to get 3x is less than negative 10, which will give us x is less than negative 10 thirds. And so we get two stretches of the number line which provide our solutions. If x is bigger than 4, then the absolute value of 3x minus 1 will be bigger than 11. And if x is less than negative 10 thirds, then the absolute value of 3x minus 1 is less than 11. The second example on the page here is very similar, and if you've looked at the other two videos, you know exactly what we have to do here. We want the structure that compares the absolute value to some constant, and then we can break it down. Here, there's a little too much clutter in the place, so what we do is we subtract that 4 from both sides, and now we have an expression that's similar to the one above. Without the number line, we'll just leap right into it and say, look, if the absolute value of x minus 2 is bigger than or equal to 6, well, that means that x minus 2 itself was already bigger than or equal to 6, or x minus 2 itself could have been less than or equal to negative 6. For example, if x minus 2 itself was negative 10, then its absolute value would have been positive 10, so this would work, and if this works, so does this. And then solving these for x, we have x is greater than or equal to 8, or x is less than or equal to negative 4. Now, I didn't do it for the example above, but since I didn't draw the number line to start this problem, what I can do is show you then the solution set on the number line. The solution set says that if x is bigger than or equal to 8, in other words, it lives here, or if x is less than or equal to negative 4, if x lives on either of those two tail ends of the number line, then this equation is solved, and so therefore this equation is solved. So you present the two parts of the number line as your solution set, either graphically or algebraically.